All right, guys. Up until now, we've been working with graphs, we've been working with tables, we've had some equations, and now we're going to start looking at situations. We did have some situations on the key features homework that we did. I think it was what's the point. We had some situations, but we're really going to kind of dive into what they mean. On that homework, we were just identifying what those features were. Now we're going to kind of talk about what those mean in the real world. Remember, when we've talked about stuff in the real world, I've always told you, when I say what's the y-intercept and what does it represent in the situation, I don't mean the y-intercept is 0, 80. I mean, what does that mean? It means the baton started 80 inches off the ground. So what does it mean? I'm asking you to describe what it means. If I say, what does it represent? I mean, what does it mean in this situation? And even if I didn't have this description, I still have this graph here. It's labeled time and height. So something flew up and landed. Even if this is all I have a situation. This situation is telling me stuff. Okay, so what is the situation telling me? Such a good question. So let's start by writing down what the key features are. I want you to take a second, and I want you to just write those features down, and then we'll come back together and we'll talk about what they mean. All right. So the y-intercept is where this thing crosses the y-axis. Well, it crosses at 0, 80. Okay? All right, so that's the first key feature. Zeros. Now, we've talked in the past about how we have either 0, 1, or 2 zeros. Well, I only see this one right here. So this is my y-intercept. That's my 0. Okay, so my 0 here is 6, 0. Is there another 0? Well, if I had an equation, there would be. But this situation doesn't allow for one. We'll talk about that once we talk about what the features are. Then we'll talk about what they mean in the real world. Okay, so up here, I have my vertex. I've done this wrong once already. This is like the third version of this video. Let's see if I can get it right this time, especially since I have it literally written in front of me. Now, we're kind of estimating for this one, right? I think this is about 2.25 for my x on the x. And it goes about up to 118, not 18, 118. So that's about the coordinates of my vertex. And again, if you thought it was 120 and you thought it was whatever, as long as it's really close. Now, if you thought it was like 150, that's not going to work, okay? If you thought this was 3, that's not going to work. So it has to be like reasonable, a reasonable estimate. All right. Now, if my vertex is 2.25, 118, my axis of symmetry is x equals 2.25 because the vertex, the axis of symmetry is the x in the vertex. All right. Now, since the vertex is the highest point this goes to, I have a max. Since the line is continuously connected all the way through, I've got continuous data. Now, for my domain, we're going to bring out our good friend Dr. XY to help us keep it straight. My domain is X, my range is Y. So I'm going to look at the X values. Now, we can box this thing in if we want to. In fact, we probably should, huh? Now, on some of the videos, some of the activities that you have or will be doing, like some of the Desmos activities, instead of having you put a box on the outside, they have you put a box over the graph, but like, it's kind of the same thing, right? Now, can I box the bottom and side of this? Hopefully what you're saying is yes, I can, because if I think about this real world situation, am I gonna, when the baton, so she's throwing this baton up in the air, like she's a band director, and she throws the baton, it flies out of her hand. When it hits the ground, is it gonna burrow into the ground and just keep on going? No, it might bounce, but that's going to be the end of the baton's journey. It's not going to go any lower than 0 inches off the ground. So I can't have any values down here. I mean, we don't really even care about the situation until she throws the baton. So whatever happened back here in negative time, that doesn't matter either. So this right here is the only time that we care about. Okay, so when I look at my domain, I'm looking at my x values. Well, my x values that I have inside the box go from 0 to 6. And again, we would write that in an inequality. We'd put the x in the middle, 0 on the left, 6 on the right, because we put the smaller number on the left and the bigger one on the right. We put less than signs around it. And then we look, do you see any bubbles? Nope. Then it's or equal to, because I could, when she first threw the thing, it was 0 seconds, and when it landed, it was 6. Okay? Likewise for the range, I'm not going to look from 0 to 80. I'm going to look at the highest this thing, it flew out of her hand 80 inches off the ground, but then it kept on going all the way up to 118 inches. So my y values go from 0 to 118. And anything in between. All right? So what do these values mean? Well, the y-intercept, when I look, if I describe the y-intercept, 0 seconds, 80 inches. And then this is all about the baton flying through the air. So at 0 seconds, that's before the thing started flying, it was 80 inches off the ground. I have to assume she was holding it above her head because I am 5'7". So that would make me 67 inches tall. And what is 80? How many feet is 80? That would make her over 6 feet tall if it flew from her head. So I have to imagine she was wildly flailing this baton above her head, and it went flying out of her hand. Okay. So this means she let go at 80 inches off the ground. I know that looks like crazy garbage, but she let go of the baton at 80 inches off the ground. Okay? Now, when I look at the zeros, okay, this thing went flying up into the air, and then gravity caught it, and it came down, and boom, right there, it hit the ground. Okay? So that means after 6 seconds, its height was 0. Well, 6 seconds height 0 means it hit the ground. So it hit ground 6 seconds later. Okay? It's like we're telling a story with math. Okay, but whatever. I know y'all don't think that's cool, but I do. Whatever. Anyway, so now when I look at the vertex, what does the vertex mean? Well, it means, remember the vertex, we've already said the vertex is a maximum. So that means the maximum height that we hit was 118 inches, and that happened after 2.25 seconds, because the 2.25 is x, which is seconds. The height is 118, which is inches. So I'm going to right here say the max, because the axis of symmetry we don't describe. The maximum height was 118 inches after, what is that, 2.25 seconds. Okay? Now, continuous and discrete, that just tells me that I can use any value in between. So I could, like if this was a video, I could hit pause at any point during this thing's path, and I could calculate the height. That it's always at some height. There's some value, no matter when I pause that video, there's some value that shows its height at any point, any time during its its trip through the air. Okay? And the domain and range, they tell me this video, if I were to record a video, it would be 6 seconds long. If I were to have a list of heights, this thing was anywhere from 0 to 118 inches in the air. And that tells me the limits. It tells me I can't have negative height, negative time. I can't have negative height. This thing never went higher than 118, so it gives me the limits. That's what the domain and range tells me is what my limits are. Okay, so let's take a look at some of these. I want you guys to tell me what's the maximum height the baton reached. Okay, well the maximum is my vertex, and the height part is the y, so the maximum height that it could have reached was 118. The label there, seriously? Hold on one second. Let's just pause for a second while Michelle, there we go. My lights turned off in my room. Miss Schulteis just waved them back on. So it's 118 inches, okay? How long did it take to reach the ground? Well, if I trace the path of this thing, boom, right there at 6 seconds, it hit the ground. All right. When was it at the same height I threw it from? Well, it was 80 inches when I threw it. We'll take a look right there. It went up and came back down, and that's just some kind of estimation happening there, but it looks like that's about, what is that, 4.25? What do I have on there? 4.2. Yeah, about 4.5 seconds. Does this have to be perfect? No. It's about, yeah, it's about 4.5 seconds. That's good. Okay. It doesn't have to be perfect because in theory I would have an answer that I could pick from. When was the baton at 95 inches high? Okay, well, here's 95 inches right here. So I'm just going to do a little highlight ski right here so we can see this. Well, look at that. It's got two values. Where was it 95? Because gravity. Because what goes up must come down. The first one was on its way up. The second one was on its way down. So at about a half a second, so about 0.5 seconds, and that was when it was going up, and then about 4 seconds when it was coming back down again. Okay, when was the baton 55 inches high? Well, here's 55. That was about 5 seconds after it was thrown. How high was it at 5.5 seconds? About 30 inches. We're going to do some more examples like this in class tomorrow. See you then.